Which brings us to another type of reaction, the single replacement. So we were talking about this a little bit when we were talking about the activity series of metals, and the reason we talked about the activity series is we need that activity series to be able to predict what happens here. The general idea is you have a metal reacting with a salt solution to form a different metal and a different salt solution. This is the single replacement. Here in the example we can see it more clearly. Copper is replacing silver in this compound, and we end up with silver by himself, and copper gets the girl nitrate. Copper reacts with silver nitrate because copper is more active than silver. He's higher on the list, and so nitrate would prefer to be with the metal that's higher on the list. Here's an illustration of that. We've got copper metal in this silver nitrate solution. And up here you can see the copper wire is thin and smooth, and down here it looks fat and kind of fuzzy because silver is being deposited on the copper wire, and the copper's going into solution. This liquid was originally colorless, and it's becoming blue because copper in solution gives the solution a blue color. We don't see the reverse reaction happening. If we mix silver with a copper nitrate solution, nothing happens because silver is less active than copper. So we need the activity series to predict these reactions occurring. Yes?
Why is salt aqueous?
Why is the salt aqueous? That's a good question. And I guess another thing I should have gone over, when a chemist says salt, they mean any ionic compound. And so these reactions will only occur in solution. If you just sprinkle the ionic compound as a solid on top of the metal, nothing's really going to happen. In the solution, in this aqueous solution, the silver ions and the nitrate ions are going to separate and mingle around. If we carry on with the party analogy, so when silver and nitrate go to the party and become aqueous, they're mingling. They're not just sitting together in the corner, gazing into each other's eyes, right? They're mingling around, and that's how nitrate runs into copper and thinks that he's pretty fine. Now, the copper's not in solution. He's dipped in the solution, but he's not dissolved in the solution. But because the nitrate is mingling in the liquid, she can come up and find him, and then they can hook up. Okay, so that's a very good question. Any other questions? So we can look at the reaction between a metal and an acid. This is a single replacement reaction. The metal can react with an aqueous acid to form a salt, another word for ionic compound. We like the word salt because it's so much shorter than ionic compound. And hydrogen gas. In order for this to occur, though, we have to consider the activity series. The metal has to be more active than hydrogen. So a metal plus an aqueous acid gives us an aqueous salt solution plus hydrogen gas. The example here is iron reacting with sulfuric acid. This is the same reaction we looked at when we were talking about the activity series initially. Iron is more active than hydrogen, and so sulfate is going to go home with iron and leave hydrogen out. So the hydrogen, you'll see bubbles of hydrogen gas form when you put iron in sulfuric acid. If we put in an active metal, one of that short list, with water, they're going to form a metal hydroxide and hydrogen. So active metal plus water, a metal hydroxide plus hydrogen gas. What can help with this is to think about water not as H2O, but as HOH. Water does ionize a little bit, little tiny bit, but it does. And so it's H plus and OH minus. And when we draw it that way, we see that this calcium is bumping out, it's replacing one of the hydrogens here. We still have the OH together. That's the girl, and she came with hydrogen, and now this hydrogen is leaving by himself. So even though when you look at this, calcium plus water, that doesn't look like a single replacement reaction, it is. And that can help you to remember what the product is, because here we have water, and we're getting rid of the hydrogen and covering that up with the arrow, and what's left is hydroxide. And we should know the formula for hydroxide ion, and so then we can predict the formula for this if this metal has a predictable charge. If it doesn't have a predictable charge, then we'll have to give you a clue about what the formula of the compound is. So this is what happens when you put calcium metal in water. It bubbles and forms hydrogen gas. So write a balanced chemical equation for each of these single replacement reactions, and for our convenience, I put the activity series up here. On the exam over this material, I will give you the activity series. I personally don't remember it either. I just look at it. So nickel metal is placed in a silver nitrate solution. Well, before we start writing an equation that we might not need, let's figure out, is nickel more active than silver? Here's nickel, here's silver. Nickel's more active. Nickel's going to take the anion from silver. There will be a reaction. And here at the end, I wrote nickel 2+. I am telling you that's the charge the nickel ion is going to have, because otherwise we don't know, because nickel's a little unpredictable. So nickel metal, Ni, solid. Silver nitrate. Well, silver is a +1 ion, and nitrate is a -1 ion. So AgNO3, and that's a solution, so it's aqueous. And that's going to swap partners. So there's silver and nitrate. The silver is going to leave, and the nickel's going to come in. When the nickel does that, it has a charge. So I'll just use what I wrote over here. There's nickel 2+, and the anion is nitrate with a -1 charge. So we need these charges so we can predict the formulas. +2 and -1, we need 2 of the nitrates to balance the charge on the nickel. And that's going to be in solution. And then what's the other product? Silver metal. And that's a solid. And then we need to balance the equation. In these single replacement reactions, nothing's happening to the girl, the anion. She's not coming apart. She's just switching boyfriends, okay? So NO3 is here, NO3 is over here. So we can balance that as a unit. If you want to balance the nitrogens and oxygens separately, that works as well, but it can take a little longer. So over here I have 2 nitrate units, and over here I only have 1. So I need to put a 2 in front of silver nitrate. I have 1 nickel and 1 nickel. Would that be a dime? And then over here, I need to put 2 in front of silver to get the balanced equation. Any questions? Gold metal is placed in a silver nitrate solution. Well, here's silver and here's gold. Who's cooler? Silver. So silver has the girl, silver nitrate. Is nitrate going to leave silver for gold? Nope. No reaction. Those are easy. We don't have to do much of anything. Cadmium metal is dropped into hydrochloric acid. So we have to compare cadmium and hydrogen. So here's cadmium, and there's hydrogen. Cadmium's cooler than hydrogen. Cadmium is more active. It will displace hydrogen. So we have to write the equation for this one. Cadmium metal always makes me think of Cadbury Easter eggs. and I'm really hungry right now. I don't know why it does that. Cadmium, not Cadbury. Cadmium metal, that's a solid. Hydrochloric acid. Hydro tells us it's just hydrogen and another element. It's HCl. That's aqueous. So what's going to happen? A single replacement. So here I've got H plus and Cl minus. The H plus and the cadmium are going to switch places. I need to know what charge cadmium takes when it forms an ion. Is that predictable from the periodic table? It's in that triangle we talked about. It's a 2 plus. So it's cadmium 2 plus, and that's going to hook up with the chloride minus. And so we can predict the formula for that. It's going to be CdCl2. That will be aqueous. And then hydrogen leaves by himself. Is hydrogen a diatomic element? Yes, horses need oats. Horses, hydrogen. So over here I write H2 in the gas state. Those diatomic elements remind me of junior high girls. I have vague recollections of being in junior high. It wasn't, the greatest time in my life. Nobody really goes on and on about how junior high was the best time in their life, right? Some people do that about high school or college, but not about junior high. One of the things I really remember from junior high was someone, a speaker or, at a pep rally or somebody pointed out that junior high girls always take a friend when they go to the restroom, that they don't go by themselves. And I was a junior high girl. And so I kind of watched, and I'm like, that's true. And I found myself doing it even though I was aware of it. So those 7 diatomic elements are a little bit like junior high girls. They're kind of insecure. They don't want to be alone. Now, hydrogen was with chlorine here, so that was fine. But when hydrogen is alone, it's going to be H2. If chlorine has to be alone, she's going to take a friend, and so it'll be Cl2. So it has to be H2. And then we need to balance this. So the cadmiums are okay, but I need 2 chlorines on this side for the 2 chlorines there, and then I've got 2 hydrogens, and that took care of this as well. Any questions about that one? A small piece of strontium metal is dropped into water. So this list is not what we need for this question. Does anybody remember or have in their notes, is strontium in the list of active metals? Yes, it is. It's in the list of active metals. It will react with water. So strontium is Sr, and that's going to be solid, plus water, and that's going to react. Yes?
It's the 4th one.
Oh, yes, strontium is in this list, but this list doesn't tell us if it'll react with water. Yeah. I think it's actually the first 5. It's the first 5 up to sodium will react with water. So, that's maybe not so hard to remember, but it just being above hydrogen only means it'll react with acid, not necessarily water. Good point. So when this reacts, what happens? It replaces one of the hydrogens. So we can think of this as HOH. And so this is what's being replaced. So we're going to end up with strontium as an ion. What ion does strontium form? 2 plus, it's in group 2. And hydroxide, and so we'll get SrOH2. That will be aqueous. And what's the other product? H2 gas. One strontium, 1 strontium. Over here we've got 2, 4 hydrogens, and here we've just got 2. So I'll stick a 2 in front of there. That gives me 2 oxygens, and here I've got 2 oxygens. Any questions? These single replacement reactions, acid with a metal, or, metal with acid or water, you need to consult the activity series.